your work with the calculator. It doesn't substitute for your work, but it does help to assure you that your answer is correct. So let's just say we were trying to simplify rad 48, okay, because you've already had that number on one of your homework questions already. So let's say we already know 16 times 3 will give us 48, and then we take the square root of 16 out, which will give us 4 rad 3. Okay, so let's just verify that with the calculator. So this is what you're going to do. Hit your y equals key. Okay, and let me clear this out. And since I'm using rad 48, and that's like, the index is 2, we're going to say 48 divided by x squared. Okay, so I did x squared because that's like the square root. Okay, so now I want to verify that my answer is correct. Okay, so I said it was 4 rad 3. So you're going to hit second graph because we're going to the table. Okay, and then we're going to get to where the positive numbers are because they're not going to be negative because we're looking at square roots. And notice you do see this 4, 3 in the table. However, you also see 212. So how do you know if your answer is 212 or if it's 4, 3? And you're going to verify this. If you continue to scroll down, this is the simplified answer because everything after that will be decimals in the Y1 column, and you can check it out. Everything else is decimals, which means this is the final answer right here. This is the simplified answer, and so you will say this will be 4 on the outside. This number that's in this column goes underneath the radical. So that's how you can kind of verify your answer. 4 rad 3 is the correct answer. Everything after this 3 will be decimals forever and ever. That's how you know you have the simplified answer. Okay. All right. So that's how you can check. Let's just put in another number. Let's just say we want to do 96. Okay. So let's go back to our y equals. We're going to hit clear. And we're going to put in 96. So if we had 96 underneath the radical, as I can, we're going to divide it by x squared because it's a square root. Okay. And then we're going to go to the table, second graph. Now, here is 4, 6. I see 224, but in between there's a decimal, but then here's another set of whole numbers. So everything after this 6, let's verify it, should be decimals, and that's how you know you have the correct answer. You can scroll down as far as you want, but you're going to see they're all decimals. So the simplified answer would be the 4 and the 6. All right, so that's how you can pick out the answer from the calculator. Okay, so it kind of just verifies, oh yeah, I got the right factors. Okay, you could also work backwards. So if I'm requiring work, then that means that if this is a 4 on the outside, we had to take it out, so it had to first be the square root of 16. Just square that number. So your factors would have been rad 16 times rad 6. So it's a way to work backwards as well. Okay, adding variables. So this is simplified radicals with variables. So now we'll have numbers and variables. So when you have numbers and variables, you do have to break down or simplify the radicand just like you do with numbers. So how do we do that? So notice that x squared can be broken down to x times x. So what you do basically is you're going to take this exponent and you're going to divide it by 2. Now, why are we dividing by 2? Because what's the index for a square root? 2. If we were doing cube roots, we would be dividing the exponents by what? 3. It just makes sense. So since today we're only going to be looking at square roots, so here are examples for all the now they're all considered perfect exponents when they're even numbers. Since the exponent is 2, 2 divided by 2, take the square root of that out, you get x. 4 divided by 2, Take it out, you get x squared, and so on. 6 divided by 2 will be x to the third. Now, what if they're odd, like 3, 5, and 7? So you're looking for how many pairs of 2's do you see in these numbers. So here you would say, okay, well, 3 divided by 2, 2 could go into 3 one time, correct? So that goes on the outside, and you're left with what? Same thing, you're looking for the pairs of 2. How many pairs of 2 are in 5? 2. There it is right there. That goes outside. You're left with 1. How many pairs of 2 are in 7? 3, because 3 times 2 is 6, and you're left with 1 underneath. Okay? All right, so let's try some of these. All right. All right, hold on once. All right, so for the first one, we already know that 16 is perfect, so you're just going to end up with 4 rad p. Okay? Not a big deal because 16 is a perfect square. Okay, number 2, 64 is a perfect square, and b squared is perfect because it's even. Okay, so we're going to take the square root of 64 out, which is 8. Take the square root of b squared out, which is what? B, because you just divide it by 2. Okay, we're dividing by 2 because of the square root. Next one, I can simplify the radicand 8 to 4 and 2. And then, of course, n squared is already perfect because it's even, so I'll just leave it as n squared. Take everything out of the radical that's a perfect square. So the square root of 4 is 2, square root of n squared is n, and then I'm left with the rad 2 underneath. Okay, so that's how your work should look. Okay, that's how I want to see the actual process. Okay, for this one here, which we actually just did on the calculator, it's going to be 16 times 3. And then r to the 4th is already a perfect exponent because it's even. So I'm going to take the square root of 16 out, which is what? 4. Take the square root of r to the 4th out, so I divide it by 2. That's going to give me r squared, and then I'm left with rad 3. All right? 81 is a perfect square. Do we agree? All right, what's the square root of 81? A to the 4th is perfect. What's the square root of that? Right, just divide it by 2. How many pairs do I have in 5? 2, so I'll take that out and I'm left with 1. Okay. All right, next one. Here's the 16 times 3 again. And then I can break this down to x squared times x. And then x to the 4th is, y to the 4th is already a perfect exponent. So I'm going to take everything out that's perfect. Square root of 16 is 4. Square root of x squared is what? X. And the square root of y to the 4th is y to the 2nd. And everything I did not cross out will remain under the radical. Okay. Any questions on that? Okay. All right. Okay. 144 is a perfect square, right? What's the square root of 144? 12. So when I take that out and there's a 6 there, I'm going to multiply 12 times 6. What's what? 12 times 6? 72. X squared is perfect. What's 2 divided by 2? X to the 1st. And then I leave the y underneath the radical. All right. Moving on. Okay, I'm going to simplify the 12 to 4 and 3. Then I'm going to simplify m to the 2nd. I got 1 pair in there to m squared and m. And then I'll leave the n underneath because I cannot simplify that anymore. So everything that's a perfect square comes outside of the radical. Okay, what is the square root of 4? 2 multiplied by the 8, by the 9, that's going to give me what? 18. All right, then we're going to go down here to the m squared. When I pull that out, that's going to give me this, what, m? And then I'm left with 3mn underneath the radical. Okay. All right, couple more. 96. We just said 16 times 6. We just did that one on the calculator. Oh, so let me write it as 16. So 16 times 6. A squared is perfect. B to the 8th is perfect. And C to the 4th is perfect. Everything is perfect. So square root of 16, except for the 6, of course. Square root of 16 is 4. A squared will become what? A. B to the 8th will be B to the 4th, just divide it by 2. And C to the 4th, C to the 2nd. And then we leave the rad 6 underneath the radical. Okay. All right, last one. How can we simplify a 44? 11 and 4, very good. Or 4 and 11, doesn't matter. Then we're going to take the 5 and break it down to 4 and 1. Okay, then we can take the 9 and let's do 8 and 1. And of course, z squared is perfect. All right, so I'm going to take out the square root of 4, which is 2. Square root of x to the 4th will give me x to the 2nd. Y to the 8th will give me y to the 4th. And z to the 2nd will just give me z. And then I'm left with 11xy.